Hi. In this video of Inkpot, we are going to be discussing homogeneous equation systems. This is the last topic in the system of linear equations unit. This is a topic that you're going to be using extensively in the unit of vectors as well. So let's get started. Now, homogeneous equation system is essentially an equation system which is represented by the following equation: A into X is equal to 0. This is a zero matrix. This is not the number 0, but it's a it's a zero matrix. Okay. Or it's a zero vector, I should say, because it's a column vector of constants and the constants are all equal to 0. Okay. The first thing to understand is that homogeneous systems are always consistent. Why? Recall that the condition for consistency is that rank of A is equal to rank of A star. Now, A is the matrix of coefficients, all right, and A star is the augmented matrix, right? But when you augment the matrix in this case, what you're adding or augmenting is a column of zeros, right? Because it's a column of zeros, it has no impact on the rank of A star. What does this mean? This implies that rank of A star is never greater than rank of A. And we already know that rank of A star is not less than rank of A, right? So we know this is not possible. We know this is not possible. What does both of these things imply? Rank of A is equal to rank of A star, which implies consistency. Okay. If you've been able to follow the argument in this horrible script, great. Otherwise, this is what I'm saying. The point is that rank of A star, when you're adding a column of zeros, it ensures that rank of A star is not greater than rank of A, right? And we already know that rank of A star is not less than rank of A because A is fully contained within A star, right? A is fully contained within A star. This was something that was already true, which implies that rank of A star must be equal to the rank of A, which implies a consistent system. So once you have a consistent system, there are two types of solutions which are possible. Okay. So homogeneous systems always consistent. You need to only check the rank of A. Because they're always consistent, naturally if you check rank of A, then you automatically know that this is equal to the rank of A star, and whether rank of A star, and whether or not this is equal to n or less than n determines your type of solution. So if it is equal to n, you have a unique solution. If it's less than n, then you have infinite solutions. Okay. And both of these are naturally consistent. So let's take an example. Consider the following matrix. This is the coefficient matrix. Let's call it A. Okay. To solve this, what will you do? First of all, R2 goes to R2 minus 2R1. And R3 goes to R3. Sorry. Just a second. Okay, so continuing with the example that we have, first of all, you say R4 goes to R1. Essentially, you're just trying to calculate the rank. Okay, so I'm going to say R4 goes to R1 so that I'm left with a matrix that looks like something like this. You have 1, 3, 13, 3, and you have 3, 4, minus 1, 6, and you have 2, 3, 2, minus 3, and 2, 1, minus 14, minus 9. Okay. So I'm just going to say R2 goes to R2 minus 2 R1, R3 goes to R3 minus 2 R1, and R4 goes to R4 minus 3R1. So this will actually give you 13 3. Okay, 2 minus 2 is 0. Okay, 2 minus 2 is 0 and 3 minus 3 is 0. Okay, now 3 minus so you were supposed to multiply this entire row by 2 and subtract from this, right? So 3 minus 6 is minus 3. 2 minus 26 is minus 24. Minus 3 minus 6 is minus 9. Okay, then 1 minus 6 is minus 5. Minus 14 minus 26 is minus 40. And minus 9 minus 6 is minus 15. Okay. Then 3 minus 3 is 0. 4 minus 12 is minus 8. Minus 1 minus 39 is minus 40. I'm sorry, 4, not 4 minus 12. This should be 4 minus 9, which should be minus 5. And this should be minus 40. And 6, yes, 6 minus 9 should be minus 3. Okay. So once you've done this, the next step is the following. Clearly, you can see that these two rows have something in common. So R4 should go to R4 minus R3. Okay. And you would then have 1, 3, 13, 3, 0, minus 3, minus 24, minus 9, 0, minus 5, minus 40, minus 15, and 0, minus 5 plus 5, 0, minus 40 plus 40, 0, minus 3 plus 15, 12. Okay. Yeah. So you are actually at a scenario where if you look at this 4 cross 4 matrix in particular, you're almost close to making it a perfect upper triangular matrix. So to, actually address the last step, what essentially you need to do is, something like multiply this with 3, multiply this with 5, and subtract these two rows. Okay, so once you do that, once you are done with all of this, the position that you get to is the following matrix. Okay. And you can see here that R3 has actually reduced to a row of zeros. Okay. Because this is reduced to a row of zeros, what does this tell you? This implies the determinant of A is equal to 0, which implies that rank of A is less than 4. Now, once you know that the rank of A is less than 4, you essentially need to see if it's actually 3. Okay, you want to check if the rank is 3, right? So consider any upper triangular matrix. To get to an upper triangular matrix, the first thing that you'll have to eliminate is this row completely, because if you have this row, then all 3 cross 3 matrices will be 0. So eliminate this row out of it. Okay, and let's consider this and this. So let's eliminate this particular column out, which means that you would have something like m3 3, yes, which is equal to, in this case, 1 0 0, 3 minus 3 0. Okay, and 3 minus 9 3. So this is an upper triangular matrix. The determinant is equal to 3 into minus 3 into 1, which is equal to minus 9, which is not equal to 0. Therefore, rank of A is equal to 3. Now, rank of A is equal to 3, which is less than n, because n in this case is 4, because you have 4 equations and 4 unknowns, which implies infinite solutions, and consistent system is obvious, but still write it out. So in consistent system, infinite solutions, rank of A is less than n. So this is the way you would solve a homogeneous equation system. The next thing that we're going to do is start with the unit on vectors. I hope that this unit is completely clear to you. Please, carefully go over the videos that have been marked as important and that have been repeatedly told to you as important topics, since this unit holds quite a lot of weightage in your exam. Thank you.